All right. So OpenFlow is currently the hot topics in networking. Very hot topic. And so we'll talk about 6 different things. Planes of networking. Then we'll talk about OpenFlow. How does it operate? Who implements them? How it has evolved? And what are its limitations? Oftentimes when people talk about OpenFlow, they talk about SDN and NFV. I'm not going to talk about them in this module. They will be talked about in later modules. So this is plain OpenFlow. Now, OpenFlow version 1.4 just came out last month, actually October, so 2 months now. And 1.4, the key reason was optical networks. Now, what is an optical network? Now, you guys have not been taught optical networking. It's just not possible to teach all that in a course here. But there are switches nowadays that do optical switching. So basically, you can program them so that the light which is coming at the red light which is coming on this one goes to that fiber, the blue light goes to that fiber, and the green light goes to this fiber. So depending upon the color of the light, you can send them in different direction. And so that is basically allows you several gigabits, even 100 gigabits of traffic to go very easily. You're not looking at the packets, you're not looking at the headers, you're just looking at the color of the light. And that can be done with a prism. Prism can easily, separate out red from the blue. Right? So it's very easy. So those optical networks can be controlled by OpenFlow by just telling the switch that, okay, now, please send the red light this way, blue light that way, green light this way, on fiber 1, on fiber 2 do this, fiber 3 do that. So for all these fibers, for all these colors, the light can be sent to the right place. It's actually much better and much easier than packet switching. So people used it, some experimenters may have used it, and now it is a part of the standard. The question is, because you have 3 colors, no, actually, first of all, they don't have red, blue and green, by the way. I just made it as an example. The light that is used is not visible light. You can use 64, 128, the number keeps going up. Basically, how many wavelengths can you use in a fiber is a matter of how good optics we have. And that keeps going. So previously we used to have 4 wavelengths, then 16, 28, 128, 1024. Now I lost track. It could be 4000 by now. I don't know. So basically what happens is the more wavelengths you define, basically all you're doing is light is a spectrum. Light is like wireless. So you have to define wavelength is nothing but a channel width. So you define how fine light can you differentiate. You see, if you take lights which are very close, they may not be very far by by the time you differentiate them, they might all fall in the same place. Right? So that is what it is that channel width decides how many wavelengths you have. And so you could have that many circuit on one fiber. Okay, and this is all circuit, by the way, not packets. This is all circuits. Everything that goes out. We don't look at the packets. We don't convert the light into electronics at that point. And then rest of it is very small. Rest of it is improved extensibility. Now TLVs were not enough, but then some places they didn't use it before. Now it's all complete extendable. Experimental extension has been extended. More information is sent when the packet is sent to the controller. So for example, it says the reason I'm sending you is because it didn't match, because the TTL exceeded, because whatever happened. So now, the controller doesn't have to guess why the packet came in. Controller can select a subset of the flow tables for monitoring. Switches can evict entries of the lower importance if table full. So that's another thing. You saw in the previous, here there is a priority field. Actually, priority field is used so that, if you match 2 entries, you take the higher priority one. So I should probably go back again. So, but this, if what happens is, suppose the controller sent them, 2000 entries and they only implement 100 entries. What do they do? So they will have to get rid of some flows that have not been used for a long time. So the flows that are not used will get out, and then what will happen is the packet do come in on those flows, they will be sent to the controller. Switches can notify controller if table is getting full. And so that is another thing, is that you don't have to wait until you are almost ready to die. You just have to tell, well, I'm 90% full, please tell me something. Atomic execution of a bundle of instructions. So that is another thing, is that anybody remembers what is atomic means? We talked about that in the database discussion. Acid was the quality of the database, but what was A for atomicity? What does atomic action mean? Yeah, do it or not do it completely. So suppose I tell you, please go there, pick up the cup, fill up with the water and bring it here. 4 actions, right? Now atomic action means that if you go there and pick up the cup and then that's it, you don't find the water, what do? No, return the cup where it was so that nothing has changed and come back. So you didn't do anything. Right? Until you finish the whole thing, the action is not done and nothing in the world has changed. If you have to stop in the middle of the action, return the whole world back to where it was. That is what is called atomic. Atomic means you cannot divide it. You cannot do half of it. Alright, so that is now possible to do in OpenFlow. You could have 5 actions, but they are atomic, in the sense that the whole group has to be done or nothing has to be done. Alright, so now here is the summary. The summary is, version 1 was single flow table and just handled the Ethernet and IPv4. 1.1 did MPLS, Q in Q, efficient multicast, ECMP, and therefore required multiple tables. 1.2 did IPv6 and the TLV matching, and then also allowed multiple controllers. 1.3 did MAC in MAC, multiple channels between the switch and the controllers. There is 1.3.1 and 3.2. Both of them are bug fixes. This line should go to 1.3.1. 1.4 is OTN. What is OTN? Optical Transmission Network. Alright, and experimentals, bundles, and table full. Okay, what does table full mean? So when you get a new entry, suppose you got a packet and you sent it to the controller sent you a new flow entry, but your table is already full. So you have to do some kind of LRU. LRU means what? Least recently used. And replace some entry with this new entry. Right? That is what table full means. You can evict. Here the word evict means throw out that entry and put this new entry there. So if you go to the website, which is mentioned all the way through everywhere, you will find all these standards. You will find 1.0, 1.1, 1.2, 3, 1, 3, 1, 3, 2, and 4. Okay, so the thing is, everybody is a different version. Alright, every manufacturer, everybody is a different version. Obviously, nobody is at 1.4 right now because it came out in October, right? Most people are at 1. Now, having said that, there are people who are coming to 1.3. Alright, so, basically, if you were to buy a piece of software, a piece of hardware, or whatever it is, the first thing you ask is what OpenFlow version you support. Right? Because they are so different. If you get 1.0, it will not support, basically you cannot extend it to 1.1 or anything like that, right? Software can always be replaced, but if it is hardware, there is any hardware, it cannot do 1.1. You have to throw away that hardware and get new hardware. Okay, the question is, if I want to buy a switch, OpenFlow switch, can I just buy the data part or do I need the controller too? Okay, alright. So the answer is, you need both. You will need a controller, preferably, the thing is still it is multi-vendor world. It's much more compatibility than if you buy a controller from Cisco and buy a switch from Juniper. That's kind of difficult. But here, so you will need to buy a compatible controller. So if you buy a switch which supports 1.3, you better buy a controller that supports 1.3.
Cisco sells the controller.
So this question is, does Cisco sell the controller unit? Yes. All right. So basically everybody that we know of nowadays sells a controller and a switch, and then you should basically match the version numbers.
So the idea of separation was to have a controller which kind of proprietary, but the switches should be like commodity because they are just forwarding and switching devices.
Yeah.
So they should be actually compatible with all kinds of controllers.
Right. The version number. So here I think though, this is just a new protocol, and we are all learning, and they are all learning, and so they didn't think about all of this, and now they had to make a jump here, such that the old this is criticism of OpenFlow by some people, is that OpenFlow is software defined, but if you are implementing it in the hardware, it is hardware defined in the sense that you cannot use the old hardware, right? Which is a weakness, right? It should be, in the ideal world, this all should be very smooth. You just need a firmware upgrade from your vendor and you are done. But it's not a firmware upgrade. If you had one table in the hardware, it cannot make n tables right away. That's not a firmware upgrade, that's a hardware upgrade. So that's why I discussed that in great detail as to what happened at 1.1. Everything else after that is sort of firmware upgrade. Alright, let's move on to bootstrapping. So bootstrapping is how does somebody come up? So when the switch is turned on, the power comes on, it should have three pieces of information. It should know what is its IP address, who is its boss, and what is default gateway. Alright? And that is the same thing that when you bring up your turn on the power on your laptop, it needs to know what is its IP address, what is its DNS address, and what is its gateway. Right? So how does it get? How does your computer get it? Either you put it in and then doesn't change, or you do DSCP. And so you need a DSCP protocol for OpenFlow. And that protocol is coming up right next to it in a minute, in the next slide. But anyway, let's say given that the OpenFlow switch has gotten these three pieces of information, then it can connect to the controller and say, okay, all right, here I am, I want to connect to you, and tell me what should I do, what my table I should fill up my table with. And then the switch provides the configuration information. It tells that I have 5 ports and this blah blah blah, and then the controller installs a rule to forward LLDP responses. Now what is LLDP? So link layer discovery protocol, LLDP. Basically by sending this, you can ask your neighbor what is your speed, whether you support link aggregation, anything else that you wanted to know, whether you support this feature, do you support Q&Q, do you support blah and blah, all that, right? So that is a link layer discovery protocol. So there will be one rule installed that says that if you get an LLDP response, it should be sent to the controller. And then it says in the next message that says, please send an LLDP request to all ports. So it sends the LLDP request to all ports. The messages come in, it does the matching, and the matching says send it to the controller. So all the responses go back to the controller. Now the controller knows what you are connected to, where you are in the world, what are their speeds, what are their capabilities. You have already told your capabilities, but now I know your neighbor's capabilities. And so now I can tell you exactly how to do your forwarding. Controller determines the topology from the LLDP responses. So that should be obvious. So basically what this part has done is that the controller has exchanged the information about you and your neighbors. The neighbor means, the question is neighbor, the controller means, the neighbor means controller or the switches. It really means the switches. Although an LLDP response will go, a question will go to the controller also, because if it says to all ports, it might go to the controller also. But really, what it really wants to know is these other neighbors. LLDP is sent by the switch.
So
Yeah, but it could be very easily implemented by sending some packet to the switch which says, instruction says, when you get this packet, please send out LLDP request to all. Yeah, so controller basically tells it to send the request. Yeah, if there is a rule already installed, first rule is that if you get a response, send it to the controller. I mean, I could be wrong on this one. This is a fine point, and it really doesn't matter. But the idea is there are 7 ports defined. All, controller, local, table, normal. Alright? And flood. So, the action might be to send to all, except the incoming interface. So maybe, it depends on how the action is sent, this LLDP request message, maybe, this is a detail that I will have to go and look into the code, is that it is quite possible that it is sent by the controller saying that, okay, forward it, and then it says, the instruction says forward it to all except the incoming, in which case it will not go to the controller. Right? And it will go to all other places, and then the other instruction says when you get the responses, it will go back to the controller only, right? So that is one way. And I think that is how it probably does. Yeah, go ahead.
I think it would be different because the controller installs a root once, and that activity takes place a number of times. So incoming interface is from a neighbor who's sending an LDDP request, not from a controller. So it will not be sent only to that port. It will not be sent to the neighbor who's actually sending it. So it might go to controller actually, because it is going to send on that port.
Okay. All right. So here thing, I am glad that you guys are arguing this because now you understand. And for those of us who really have to really resolve this, we'll have to read the code, and which is none of us actually at this point. But the idea is that there are 2 possibilities. One is that the request starts from the controller, and like any other packet, that packet is seen by the switch, and then it says what to do with this packet, and it says, okay, send it to all. And so that is one way. Second way is that it could be just an instruction. Somehow it gets to the switch, and I don't know how it gets to the switch. And then the switch says, okay, all right, I have to execute this instruction, which means send to all. In this case, it will send that to controller also. And since we don't have the details, I would stop it right there. The question people are asking is, where does the LDTP request start from? Does it start from the switch or does it start from the controller? That's the question. If it starts from the controller, the responses do not have to go back to, the controller does not have to respond to it. If it starts from the switch, then the controller has to respond to the LLDP request. Right? Okay, so that's why we don't know. We don't know where the LLDP request starts from.
So that is like there are 2 ways to do that, right? As I said,
yeah, right. So
that's listens to all broadcast type of things. It just listens to everything, and that's the information it requires. Or it actively starts the LLDP process itself.
Right. So those are the 2 possibilities. LLDP is one-way protocol. There is no request and no response. You just send the LLDP to your neighbor, and that's it. So LLDP is a kind of a broadcast protocol. You just send it to your neighbor, and every so often you just send it. And so that basically has been corrected, and this is how the bootstrapping is done. Controller starts a rule to forward LLDP packets to the controller. So every switch has this rule that if you get any LLDP packets, please send it to me. And then sends one by one LDP packets to be sent out to the port I equal to 1 through n. So then it sends, if it finds out that you have 4 ports, it sends you 4 LLDP packets, says send this to port 1, send it to port 2, send it to port 3, send it to port 4. And so obviously the switch does that. Now the neighbors have the same rule. Neighbors have the rule of forward the package to the controller. And so they send it to, the neighbors send it to the controller. And so now it knows exactly who is connected on what port.
Also in the specs it is written that the controller creates the LDTP packet.
Yeah.
Not only the rule, but also it creates the initial packet.
That's exactly what he's saying. Okay, that and then sends means the controller sends.
Sends. And
Yeah.
then they send to the neighbors.
Yeah, controller sends n packets to the switch to be sent out to the neighbors, and those n packets are forwarded to n neighbors. So last time we were not sure where the packet starts. It starts from the controller and ends at the controller.